What do you guys think about that? Anyway, I'm Beth, so I'm one of the co-organizers for DFW Big Data, so many of you have met me. I also work at Divergence Academy. We're a data science school. We're going to be launching a cybersecurity program in the fall. We're also going to be launching cloud computing and DevOps programs, but we teach both on-site in the classroom or in the building right behind us. And anyway, it's a really great program, so if you're interested in that, take my card. I'm happy to talk with you about that. We've had this meetup for probably about 3 years. So who's been coming for 3 years? Barry comes all the time. Yeah, so welcome. It seems like as big data is kind of like transforming and changing, every meetup we're getting a different audience now. So we get a mixture of new people and people that have been working with Hadoop for a long time. So who's new to Hadoop? And who feels like they're pretty experienced? Is that a half race? Who's scratching his nose?
I'm pretty much using it.
Okay, good. Yeah. Yeah, but I think since the weather was so beautiful, we had a lot of people that probably were driving this way that head over to the big data park. You know, so since we...
Good answer.
All right, well, let's see. Who wants to introduce our speaker? Anybody? Anybody from Gluent?
I can do it myself.
You can introduce yourself.
Usually I do it myself.
This is Snell. How do you say your name?
It's complicated. So when I'm back home, Estonia, where I'm from, I say Tanel. Tanel, yeah. But when, you know, actually how you spell it is with an A. When I said Tanel, then people started imagining long tunnels, and they wrote the U. So now I say I'm in Tanel. So I just adapted my name a bit.
You're in Texas.
I'm in Texas, yeah.
And Texas 10L.
I nail.
You guys are welcome to scoot up to the front row.
Yeah, getting closer. We still have like probably like half pizza per person left there, and there's free beer back there. And
oh yeah, I forgot to mention Gluent. Thank you. They brought all the wonderful drinks, so we need to drink up.
yeah, before anybody can leave, we actually have to drink all of the beers.
And our beta solutions provided the pizza. David's not here tonight, they provided pizza, and Addison Treehouse is wonderful and lets us use their facility.
Yeah, awesome.
One more thing, the video will be up on my YouTube channel in about probably 4 to 6 weeks. I've got 2 other meetups queued up. So it's translation data, that's my YouTube channel, okay?
I think you can add also, like, you know, in the meetup page, you can add a comment later.
Oh, yeah.
Yeah, I mean, so I actually have a slide with who I am and who we are at Gluent as well. So I will start from the right side. So I'm a long-time computer performance geek. I've used Linux or hacked Linux since version 0.97 something. It actually, when Linux began, then for quite a while it was version 0.95, 96, 97. Then it got too close to 1 and they started adding like 99.8 or something like that. So someday there was 1. But, so that's like since 1993, I think. With Oracle, I've done Oracle stuff for 20 years, and I immediately got really excited about how complex it was. You know, being like a young hacker, you actually like more complex things. Now it's kind of like backfiring, it's too complex. But indeed, there was a lot to learn, and I dove very deep into internals and performance and how this complex piece called Oracle interacts with your OS and the storage under it, and you know the whole end-to-end thing. And when Oracle released Exadata, then I was one of the co-authors of the expert Oracle Exadata book. Kerry, with the hat back there, was the second one, and one more guy from Entech. So we actually, or Kerry bought the whole quarter rack Exadata appliance and just took it apart, put it back together, took it apart again, put it back together, and then learned. So yeah, a long-term, hardcore Oracle enthusiast. I still like the Oracle technology, but I don't think it's the best thing for everything anymore. 10 years ago, in my mind at least, it was best thing for everything. But now there are so many workloads where Oracle should not be used, because there are so many better options. But there are workloads where Oracle still should be used, like complex transactional systems and ERP systems and stuff like that, right? But your analytics, data sharing platforms, archiving, like big data sets which you scan and filter and then aggregate and whatever. So that's which is not transactional especially. That will all go away over time to modern platforms like Hadoop or something in the cloud and so on. So that's the right side, and so I was a consultant like for a long time, just helping customers solve their problems. But now I'm a vendor. So, but I will keep it civilized. So if at any point of time you get bored or whatever, then feel free to speak up. So I'm still a very technical vendor representative. So that leaves us to the left side, so Gluent. So I co-founded Gluent with a few partners, and the reason for Gluent to exist is that we saw what I just explained, right? So you have these existing enterprise systems based on Oracle and SQL Server and DB2 and so on, built over tens of years, but now we have all these new magical platforms coming up as well, which can do some things much better or cheaper, right? So how do you glue these two worlds together? So that's what we do at Gluent, and I'll show you what. In general, this presentation is about. It's about something called hybrid world. That how do you use the power of Hadoop for your traditional enterprise applications, just like the title or the title said, right? As this is a big data meetup, so I didn't plan to explain what is Hadoop much, right? So, but a couple of people said that they were new. So I will explain. I'm not going to really explain what Hadoop is in detail, but really, why do I like Hadoop so much? Being a database guy, I've worked with very complex and sophisticated databases. Why do I like Hadoop now more than these complex and sophisticated databases, right? So number one, I guess, I don't know it's a specific order, but one of the items is obviously that it's super scalable, right? So there are companies out there who run, I actually have it, who have multi-thousand node clusters. So Facebook has had, for years, they've had like 4,000 or 5,000 node clusters and multiple of them. Facebook had like a 30 petabyte Hadoop cluster 6 years ago already, right? You couldn't do, or you still cannot do these kind of things on your one big EMC storage array where you put together, where you load where you connect a lot of servers directly. So these monolithic systems don't scale, right? So Hadoop is designed, that instead of buying these very big boxes and very big storage arrays and putting very expensive fiber channel pipes between them, right? Instead of that, just buy the cheapest servers possible, put disks right in them, right? So if you have a 10-node cluster and that's not enough, you add 10 more nodes. Each new node has their own disks in it and direct connection from storage to the node, right? So you can grow to a 1,000-node cluster if your business needs to, and you still can do I/O fast enough. You will not have this typical storage array I/O bottleneck like everybody else has experienced when they wanted to do big databases, right? So it's scalable, and as I mentioned, disks. Every Hadoop node tends.
He's got a question.
Yeah.
Is that how Facebook is structured then? How you're just describing?
Yeah, I mean, so there is a next-gen thing as well. I mean, networks have gotten so fast that most modern companies actually have gone back into the beginning. That you have some network, you have a storage node separate and really fast petabit scale network in between, and then Hadoop nodes. But please ignore this. So this is like just too advanced. So most companies who run Hadoop today, like Facebook's, Yahoo's, and so on, then for their analytic platforms, they are structured like that. Okay. So you add more nodes. You don't only add more CPUs and memory. You add disks within these nodes, connected straight to the compute power, right? So, but yeah, some companies have gone beyond that with very fast networks. So, and the second thing is that the mantra of Hadoop is that now that you have this 100-node cluster, for example, that you want to run some analytics, scan through a lot of data, aggregate it, and do some sort of reporting, then the Hadoop analytic engines and SQL engines like Hive and so on, right? They're designed to push down processing close to data, on the disks, right? So that the old school approach was that you had a really big EMC storage array. You took all the data, pulled it into Oracle, and then Oracle sees that, hey, I actually don't want to see half of the data. I'm going to throw it away, right? And then it aggregates and then sends you back your report, right? Hadoop mantra is different. That, hey, whatever you want to do, scan, filter, aggregate, join and stuff like that. If possible, push that close to the data. Push it down close to the data. And the mantra is that moving computation is cheaper than moving data. Push your aggregation and filtering down as opposed to pulling all your data to your CPU and throw data away with the infancy. Next, Hadoop is software defined, mostly open source, right? Well, Hadoop itself is open source completely, right? But there are some vendors like Mapr who have their own proprietary file system. Looks like Hadoop. It's not the actual open source Hadoop, but it's similar, right? And they have their own advantages and so on. So, and everybody likes open source from that angle that it's going to be less lock-in, right? I mean, you always have lock-in, right? So even with open source, because it's hard to rewrite even open source from one open source platform to another and so on. But it's still less lock-in than with a completely closed software, right? So yeah, and Hadoop is designed to run on commodity hardware. So don't buy a server from Sun or IBM. There are companies. I mean, if you asked about Facebook, right? If you have a traditional company, a typical company who's not running very big data centers, they will go to Dell nowadays or Supermicro, and there are these vendors who just build cheap servers, right? But if you go to Facebooks and Googles and Yahoos, these cheap servers are too expensive for them. They design their own. They remove all these little components what you don't really need when you just do custom-built servers. And then they take these designs, send it to somewhere in China, and then they get a bunch of servers back, which only have like as minimum hardware in it as they need. And I'm kind of getting sidetracked here, but even to the point where a big company goes to Dell and says, I want your servers, I don't want to build my own, but build me a version where there is no Dell logo in the front. Because Dell logo takes up space and less air flows through. Therefore, you generate, you use more heat, or you generate heat, and you need more power for cooling the heat, right? So you remove that, and you get like 0.5% of efficiency. So at that scale, these guys are doing things like that. And again, like a typical company doesn't really need to go to 4,000 nodes, right? But the typical company, what they win from Hadoop is that instead of paying $10 million to a SAN storage vendor and the vendor like Oracle or Teradata, instead of that, they will just pay $500,000 to get some cheap hardware, cheap Hadoop, and then spend another half or $1 million on putting all those components together, because they might not be as well integrated as your 30-year-old solutions. But it's still, $2 million instead of 10 million, right? So smaller companies don't need 4,000 node clusters, but they can benefit from cheaper clusters, and more, and you still get more I/O horsepower and so on. So yeah, Hadoop is definitely scalable, and whatever you hear about Hadoop, make sure that this information is current, right? 7 years ago, Hadoop was mainly MapReduce, and you wrote Java, right? Today, Hadoop has like 10 SQL engines on it, right? You pick what you want. Hive, Impala, Presto, Drill, blah, 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 right? 5 years ago, Hadoop was not secure. If you could connect to that port, then you were admin pretty much. But now you have Kerberos authentication, you have SQL engines have LDAP authentication. You can grant privileges to tables and stuff just like in your Oracle or SQL Server database. And you can have encryption, the whole distributed file system, every directory can be encrypted by different keys. So it's very powerful. So whatever thing, if somebody complains about Hadoop not doing this, make sure that this info is current, not from 2010, right? Okay? And this is been talking for a while, so so this, and the last thing is that because Hadoop is open source, then the data formats are open, right? If If your data is in Oracle or SQL Server or Teradata, you don't own your data. If you have to pay a vendor to use your own data, then you don't really own it, right? In an open source data format, you finally own your data. You can actually run whatever engine you want. So, and that gives you this. One data, many engines. And this is what I like about Hadoop the most, right? So these are all kinds of Hadoop. The HDFS is the file system, and these are all kinds of Hadoop open source data formats which you could use. Some are columnar, some are just text and whatever. So, but where I'm getting at is that because these are open data formats, open source defined formats, then many of the Hadoop engines, like Hive SQL engine, MapReduce, Impala SQL, they can all access all the data, right? Previously, you didn't like Oracle, you had to take your data away, you exported it away, you loaded it into Teradata. Now you have data in 2 places, and you could now finally run it in Teradata. But with this approach, you can actually, if new engines show up over time, then you can just install that engine as well, and it can analyze the data what you already have gathered. So that's a very powerful thing about Hadoop. Okay, any questions about that? So, I mean, you probably already see I like Hadoop a lot, but so Hadoop doesn't do complex transactions. You can have scalable, simple transactions like, hey, here's my shopping cart, I'm going to put it here, and later I'm going to get it back. And then I will update that shopping cart. But if you run an ERP system, then don't dream of running that on Hadoop anytime soon, right? ERP systems are like, hey, I'm going to update 10 records in this table, then I'm going to update 50 here, I'm going to delete one from here, I'm going to insert 1,000 here, then I will go back and update some more, and then you commit the transaction, right? Complex transactions across tables and so on, Hadoop doesn't do it yet. It's not really designed for that. If it were designed for complex transactions, it wouldn't be as scalable. That's the trade-off, right? It's much easier to scale single row transactions where you immediately come. So that's one thing. And the second thing is that, again, like if you want to run a typical transactional enterprise system, you know, take it from your relational database, you don't really have something like a transactional PLSQL. You could run Spark jobs and whatever, run your own code on your data, but it's not exactly the same, like running a order processing batch job and stuff like that. And Hadoop doesn't do very complex queries, right? Well, not yet. It's very scalable and very fast for your simple to medium complexity queries. But if you come from Teradata world or Oracle world, then you get surprises. Some syntax, like, you know, subqueries work, but and in some engines correlated subqueries work, but then you have an OR statement and 2 correlated subqueries. Then the SQL engine says, nope, that's too complex for me. And you would have to write your own code to, you know, maybe run 2 queries and just join it together. The reason is this, that Oracle and Teradata, I don't know, IBM DB2, these guys have built their SQL engines for the last 40 years. And as they've grown, they have like 1,000 people working on it or whatever, right? So, and the Hadoop vendors, Hadoop SQL engines, some of them are like 2 years old. Hive is maybe, Facebook invented it, the Hive is maybe 7 years old, or maybe 8, right? But they never had that many people writing code, so it's not as sophisticated. So if you come from a relational, enterprise relational database world, it's, you get some surprises. So different trade-offs. Hadoop is great at some things, your relational databases are great at other things, right? So, and that basically, you know, how do you use the best of both worlds. And the last thing about Hadoop is that is Hadoop only for big data, like web log processing and indexing, and well, again, Hadoop 10 years ago was only good for big data and, you know, web log processing, but as of today it can do a lot of reporting, analytics, warehousing, GIS, graph databases and stuff like that. So Hadoop is not only for big data, and this is what I'm thinking about. That. So that's hopefully one thing you remember about after this evening here is that Hadoop is not only for big data, it can be very useful for this small data or traditional data. Even if you don't have 1,000 nodes, even if you only have 20 Hadoop nodes, you can do some things much cheaper and much faster compared to your old school database. Okay. So at the top part here is Hadoop for big data apps. I'm mainly, because the background where I come from, I'm interested in this part. What about using Hadoop for, not only for your new IoT and big data apps, but what about using it for your existing stuff, what you've built over the last 25 years, right? Okay, so basically, how do you connect all of these magical words, new big data sets, existing whatever apps, your databases you have, and use these platforms? Okay, and the answer is hybrid world. How do you get the best? How do you get Hadoop to do what it's best at, and have your databases, existing apps, do what they're best at? Okay, so I'm going to show you some examples in a moment, and actually what we see other customers doing, right? So, but visually, it's basically this: that I think Hadoop is going to be the center of universe for many things, like analytics, reporting, data sharing, archiving, and all the streaming, all this kind of new stuff tends to go into these new platforms as well. Maybe you have Kafka running on a Hadoop cluster and stuff like that, right? But these old school database engines are not going to go away anytime soon. I don't know about Teradata, but these engines they're just too good at what they currently do, complex transactions, right? And now, how do you achieve the hybrid world where Hadoop would do what it does best, and your apps do what they do best? So basically, you need these arrows in between. So you need a way to somehow easily get data from your Oracle database to Hadoop, but also your existing applications should be able to query Hadoop data as well from within their database. So that you wouldn't have to load data from Hadoop to database and then query it, right? Hadoop should be the central data lake, which can do a lot of heavy lifting for you. Like I mentioned, whatever it's good at, the big data sets, and then the running analytics, and so on. So you need these two-way arrows to make the hybrid world possible. And there are multiple vendors doing this. Gluent is one of them, right? So, but there are multiple vendors doing that, so I'm going to mention some of them. But I'm going to kind of talk about the general idea of a hybrid world, right? And I will show a couple of examples as well. So again, and it helps that you have open data formats here, because if data was locked into some specific single vendor format, then other databases, other apps couldn't use it. But thanks to open formats, once you load data to Hadoop, or once you offload data to Hadoop, anybody can query, who have permissions, of course. Okay, so I don't expect you to read all of this, but this should be on the video, just to show that there are related vendors. So the old school vendors were ETL vendors, right, or replication vendors who moved data around wherever you needed. You had multiple silos, and you needed to query data in this silo. You had to replicate it from one silo to another, and then use it. So that's the old school way of sharing data. You duplicated it, right? But now there are a bunch of vendors. Well, one vendor is Gluent, as I mentioned, but there are vendors. Every big database vendor has realized that such a solution is needed, and they've built a point solution for their own databases. So Teradata has a tool called Query Grid, which allows you to query Hadoop data from the database, right? SQL Server has something called Holobase, which does the same. Oracle has Big Data SQL, IBM has Big SQL, and if you don't want to pay extra, if you don't want to buy these from them, then most databases, or maybe all of them, for sure, Oracle, SQL Server, and Postgres, they actually have like native database links built into them. So for example, in Oracle, you can install an ODBC driver next to the Oracle server and query MySQL, SQL Server, or Hadoop data from your Oracle database directly. And that's not extra, that comes within the Oracle database or with the Oracle database license. And your Hadoop vendor gives you ODBC driver for Hive or Impala. So but this is not, it's not very fast, and you kind of have to set it up yourself. It's not good enough for big analytics stuff, but it's good for archiving and stuff and so on. So I'm just kind of showing that if you want to get started and you don't want to go to a vendor to buy some product just to connect your database with Hadoop, then there are ways to do that as well, right? with built-in database links. Okay, so I'll show you a demo of how we do it, how we achieve the promise of hybrid world, and then I'll show you later on what other customers are doing and how people benefit, how people make their existing apps benefit from the power of Hadoop. Right? Hopefully that kind of generates some good ideas to what becomes possible with this. So this is actually a two-minute demo, and I'll that how we do this. So that if, for example, let's say that you have a big Oracle database. Again, my background is Oracle, so that's where I usually start from. You have a big Oracle database. It's growing and growing, and it's very expensive, right? Your storage array, SAN storage array, gets bigger and bigger. The IO bottleneck gets bigger and bigger when you want to scan through a lot of data, right? So we have built these arrows, what I mentioned, for the hybrid world, right? So before you kind of offload any data, we actually have a tool called Advisor, which can look into the hotness of your data, which partitions are modified too much and which are cold, and we can actually analyze that, hey, out of this 76 terabyte database, we'll just move this away, out of this 76 terabyte database, that this amount of data is tables and indexes, this is some other stuff, temp tablespace and so on, and out of this candidate data, so to speak, 91% of data would be safely offloadable. So I could actually move 91% of data from this big database to Hadoop and shrink my database, right? So that's, what we do here is we look into that it would be also safe, that your performance wouldn't suffer. So I'm just going to show what happens. So this is a video, so I don't want to rely on VPN and Wi-Fi. So and now I will click into this heat map, which kind of shows me that, hey, this is the Oracle database, and this is like a partition. I can select like how many percent I would want to offload from this database, and I just selected, hey, 75%, and all the, I don't see any red partitions of the tables here, and let's try 95%. You see. Then it's a bit too much. I see red, too hot, too frequently modified partitions on Hadoop. I probably don't want to put them there yet because they are still transactionally modified and not matured, so to speak. So I will go back to 90%, and that looks doable. And I can kind of go down and either offload this whole database, whole 90%, what I selected, or just pick that, hey, I actually want to offload one schema called sales history, and I actually have synced the data already, so it will just do like an incremental sync. It sees whatever has changed, it will sync this data to Hadoop as well. So I'm not actually copying 70 terabytes of data right now. I'm just doing an incremental sync, right?
You said offload or sync?
It's the same thing. So it's data offload, but over time we started talking about sync. So it's the same thing. Two different names for the same thing. So maybe it's worth saying that when by offload usually implies that you take data from here and you move it somewhere else, right? We can do that as well, but by sync I mean that usually we just copy the data. That first the data resides on both sides, both in the database and Hadoop, right? And you can drop the data later whenever you're ready. When you see that, hey, this thing still works, it's fast enough, and then you drop it later. So sync means copy. Offload kind of implies that you copy and drop the data from the source.
Okay, can you in the previous 5 minutes or whatever you were showing, you showed that the Oracle size was shrinking.
Yeah.
Is this a different use case that you're showcasing, or is the same use case that you're showcasing?
Well, it's the same use case, so that you have a big Oracle database. Then step number one is you copy data to Hadoop. Now you have the same data in Oracle, same data in Hadoop. And then the next step is you drop it from Oracle side, right? And then your Oracle database shrinks.
So for the end user, it appears that this is just one happy big database.
Yeah, yeah.
Except that the query times depend on where the
Yeah.
actual data is.
So as a next thing, I will actually show how the queries run, right? So that the whole point is that if I move the data away and I dropped it from the database, and you know, by default, you will lose access to your data, right? So if I had vanilla Hadoop, vanilla Oracle, I moved data over, then my Oracle application wouldn't see the data anymore, right? So, and that's where I'm getting at with the hybrid world, that in a proper hybrid world, you will use a tool, either from Gluent or from other vendors, or an ODBC driver, like I mentioned, which can do hybrid queries across the whole data set. So for the end user, for the end application, nothing changes. They just see that, yep, it's the same data, but under the hood, some data gets pulled in from Hadoop.
So it's almost like a cache, essentially.
It's not even cache, because we don't cache the data in Oracle. We just whenever for every query, we'll just send back whatever is needed. I'll show it. I'll go on and I'll show it. But the keyword is hybrid, in the sense that you can run a hybrid query across your relational database and Hadoop, and to the user, it looks like all the same data set. So I clicked next, but this is a video, so I'll just go on. And now, so this is a pretty technical demo because I'm a techie. This is an existing query, right? You know, you may have some GUI reporting tools or whatever tools. They have nice GUIs and charts, but in the backend they all run SQL, right? In the backend they will just send SQL to the database, right? And this is an example of an Oracle SQL. So it's an Oracle syntax. It's a fairly, you know, it's medium complexity SQL. It's not very complex, but it has Oracle's PLSQL in it. I have delivered the proprietary Oracle's procedural language in it, so that just to show that I cannot take the SQL statement and paste it into Hive or somewhere else. It only, because it has Oracle proprietary stuff, it only runs in Oracle, right? And I will run this query twice. So before I run it, again, this is a technical demo. You see, left side, this is an Oracle server. It's a very expensive server. It's actually an Exadata machine. Every CPU core Oracle license list price is $100,000. List price is $100,000 per CPU core. So, and this down here is a Hadoop cluster, which is very scalable, very cheap, right? You don't have to pay anything for it if you don't want. But then, you know, somebody has to give the support for it. So, and I will run this complex query twice, or this medium complexity query twice. So once I will run it all Oracle, it's all in the old way. You see, without Gluent, I haven't enabled the Gluent hybrid query yet. And you see, it burns 16 CPU cores. It's a parallel query. It burns 16 CPU cores. Let me move this away. 12 seconds. Down here, you see, it's almost 12 seconds. It used Oracle storage, or the storage array on Oracle side, Oracle CPUs, and you know, for all the work, just like in the old days. Okay, 11 seconds. And now the only thing that I will do is I enable our version of hybrid queries. I just enable this for those tables that I have synced to Hadoop, right? So any table I have synced to Hadoop, they became like virtual tables now, and actually either all or some data they take from Hadoop. So I will run exactly the same report. I'm not changing a single character. I'm not even logging out from the database. It's in the same database, right? So it's not, I'm not pointing my app somewhere else. It's the same database. I'm still logged into the same place. But I have virtualized the table, right? And boom. Instead of 11 seconds or 12 seconds, it runs in 2 seconds now. And this is now where the vendor thing comes in. That this is too good to be true, right? If something runs for like 5 times faster, barely use any CPU. So, you know, it must, either the vendor is lying or the system does something radically different than before, right? And what's radically different than before in our case is that we are using Hadoop backend. You know, this scalable and cheap Hadoop backend for most of the heavy lifting. because we had already synced data to Hadoop, the biggest tables to Hadoop, and thanks to that, we can push down scanning, decompression, filtering, aggregation, all this heavy lifting activity down to Hadoop. And whatever we could not push down to Hadoop, that's still, that data is still sent back to Oracle, and Oracle does the last pass of processing, like PLSQL and whatever it needs to do. So, and why this is significant is that I just demonstrated to you that it is possible to make an application 5 times faster and use way less CPU, these expensive CPUs, without rewriting that. Right?
How much data is that?
That's the table is we had a 5-table join. The biggest table that I offloaded was just 1 billion rows, so it's not a very huge table, but it's 1 billion records. And the 4 other tables in the join, they were still in Oracle. So by hybrid query, I mean you can actually query 1 table from Hadoop and 4 others from Oracle. Or you can get all from Hadoop if you want to. Yes?
Did you have to modify the query to run that? Is that the same query running?
It's exactly the same query, yeah.
Okay, so are you running the SQL compiler?
So am I running the SQL compiler? It's so basically yes and no. So we are not rewriting SQL text. We are actually virtualizing individual tables. So Oracle is still the one who puts together the execution plan, who compiles the SQL.
Okay.
But instead of querying an Oracle table, they query our virtual table, which is
Okay.
actually an external table. And we've made the external table smart, which that before it goes to Hadoop to get data, it only gets the data that the query actually wants to see. So we have Oracle compiles the execution plan. We read that execution plan, and armed with that knowledge, we know that this query, this user needs to see only these columns and these rows from that table.
Okay.
Instead of sending back 1 billion rows, like in the old world, we will only send back maybe 1 million rows and a couple of columns. And that's how we can push aggregations down and so on, and that's how we get Hadoop to do the heavy lifting for us.
If you go to like the Hive shell and execute that subset of the query, how would it still take 2 seconds? And that seems awfully low to me.
If I go to Hive shell and run this query, I mean, why is it so low? Let me see. That's it. Instead of having the storage bottleneck, instead of having this few expensive Oracle CPUs doing the work, I have many more cheap Hadoop nodes doing the work for me.
But in this case, how, as far as going back to the question, that how the transformation is happening. So let me put it this way, the way in which you said virtualizing the table of the Hadoop.
Yeah.
Right? But how it take the syntax of the Oracle.
Yeah, we translate it. So
Right, that's what it is.
yeah. But the point is that if you have a 20-table join, a big complex query in Oracle, and only 2 tables are in Hadoop, so we are not going to try to somehow translate the big Oracle query. We only generate queries for these 2 tables. So Oracle still does the 18-table join in Oracle, and we only fetch data from these 2 tables. So we don't have to translate the whole query. We only translate the subset of your execution plan for fetching data. So that's the kind of the technical part, and we have beer, and once I'm done with this, I'm happy to kind of go deeper into technology. And other vendors, there are some other vendors who have some similar looking solutions, right? But that's how we do that. And actually, there's a video. It's a 1.5-hour video where I explain this whole process, and it's more demos and so on.
Yeah, one quick question. So
Yes.
if you are talking about the pros, what about the cons? There has to be something.
Pros and cons, that's a good question. So this hybrid system is great for analytics, reporting. Like even now when we use Impala as a backend, any query which runs for a couple of seconds or more than a second, it's offloadable. It gives decent results, right? But if you have an OLTP system and frequent transactions and index-based single row lookups, then don't drop this data from Oracle. You can still sync it to Hadoop if others want to use it, right? But don't drop it from Oracle. Let Oracle do things the old way.
So running these queries in the Impala, you face like data skewness, like running the joint operation from billions of rows.
Yeah, so it's when we run Impala queries on billions and billions of rows, one of the benefits is that if it's a complex join, then a part of the join happens still in Oracle, right? So but we have had things like where we have a fact-to-fact join, And we actually have pre-joined the table into one big one in Hadoop side, so that we wouldn't have to even do that. So yeah, we have seen some, usual query issues there, but it's just kind of this can be worked around by when we offload data, we can decide what kind of data model we should have on Hadoop side. I would propose to leave the tech stuff to then, because I want to show what customers are doing. So, like 3 years ago, we actually went to conferences and started talking about hybrid world. It was pretty much just us talking about it, right? And now customers are actually doing it, right? So there are some banks who, whenever they deploy an Oracle machine, they put a Hadoop machine just next to it every time. Sometimes only for archiving needs, but sometimes for actually offloading needs and heavy lifting needs. So
in this case, even can you go for the very complex queries or no? After using.
So can you run very complex queries? The answer is yes, in the sense that if you have a very complex query but you offload only one big table or a couple of big tables to Hadoop, right? Then the big complexity still happens in Oracle, right?
But it will be just simple query for the whole.
Yeah, and because we don't offload the whole query, we only offload like a subset of this query plan, execution plan 3, then the Hadoop gets a pretty simple query, right? Yes?
Can we offload only partial table, like only certain set of rows?
Yeah. Can you offload only partial tables? Yes, so that's what we go by the, well actually I'll show it visually as well. You can offload all tables if you want.
No,
you can offload only.
Set of data, like, let's say we have data from 2009 onwards.
Yeah,
You want to,
yeah.
Take off all
Yeah.
the
So I start from, like, you can offload all tables entirely, or you can offload only some tables in your schema, or you can only offload the last 6 years of history from one table and leave the last, remaining year in Oracle. We call it a 90-10 table, right? 90% in Hadoop, 10 in Oracle. And I'll actually show it visually as well.
I'm sorry. So say for example, you have the phone numbers of everybody in the United States, right?
Yeah.
You just say that. But the thing is, it's only like per person. Say for example, you only have one record.
Yep.
Right. So which basically means that you have to have updates and stuff.
Yep.
Like that. How would this work in that sense? So there's only one partition.
Yeah.
There's no partitions there.
Can we sync updates? Yes. So HDFS itself, Hadoop, the distributed file system, HDFS is not modifiable. You can only create files, append to files, and delete files. You cannot go in the middle of a file and update it, right? With Gluent, what you can do is you have a dimension table with customers, right? You can sync the whole dimension table to Hadoop, keep it on both sides, right? And when somebody changes something on the database side, we can take this one changed record, and we will put it into a Hadoop side into a Delta log, right? And users don't query this big table directly, they have a merge view on top of it. So we can later run compact, and so basically, long story short is, we can sync changes to Hadoop, and to users it seems like data is being modified.
So from the Hive itself, it looks.
Yeah, because we use a Delta view. The user doesn't query the data directly. The view kind of presents the latest state.
So you have a serializer or something like that on top of it that you wrote, or?
Yeah, we wrote our own logic there. I recommend let's go on with the case studies because some of them are very cool, and I can explain the details later. And the video has details as well. And that's what we call orchestration. Is that Hadoop is awesome, but it's not 40 years old, So you get this awesome platform, and then you end up realizing that you have to write a lot of code, or somebody has to write Python or whatever. So we've done a lot of this orchestration so that it would be a single command for you. All right, so I'm going to go on. There is more cool stuff to be seen. So case studies. So customers are starting to see that. Number one, here in Texas, there's a company called Securus, and anybody from Securus, no? You know them, yeah. And they're like a reference. Yeah, they do phone systems for prisons, and they manage them, and they have their own phones, and they do all these IT services for that as well. Because whenever a prisoner calls something, it needs to be logged, and prisoner may not call some specific numbers, and then the calls can be recorded unless the prisoner talks to the lawyer and things like that. So whenever somebody makes a phone call, their system does a bunch of lookups and computation, and then allows or doesn't allow the call. So that's one thing that they do. But they do something even cooler. So they have a subsidiary called Satellite Tracking of People. STOP. So it's an IoT app. IoT, and IoT is ankle bracelets. So it's an Internet of Things attached to convicts, right? So so And architecturally, what they have is something like this, that you know, if people have ankle bracelets, and every 30 seconds they take the GPS signal where the person is, and then they send this GPS signal via the phone lines or the mobile signal to their system, right? And this system now keeps track that this person must be at home every time after 7 p.m., right? And if they don't, there is an alert. Or this person may not go close to kindergarten, right, ever, right? So it's IoT, but not for some marketing or optimization reasons. It's IoT for very serious reasons, right? And because this system was built a long time ago, it was built on Oracle. They had a lot of incoming data, and 7 years ago or whenever they built this thing, Oracle was the best choice for these kind of apps, right? But now this database was kind of falling apart. It just, you know, keeps growing and growing, and you have the typical problems with storage throughput and size and cost, right? And now they have all the challenges of how, you know, they want to sell their services to more states, right? So, and you know, add more parole officers who can look at the data, do advanced analytics, you know, so that they wouldn't be reactive, but they would actually kind of do statistics and or maybe even predict something, right? This is that. It looks like from spy movies, you know, where you're going to have satellites and then people zoom in and stuff like that, enhance, you know. And you know, here they have just looked into one person, and obviously we've blurred it all and validated that we can show this, or we verified with the customer. But so this is, I think they looked into, that's 4 days of history here, so that's actually with Gluent already. So the problem there was that when you have such a big data set, on this Oracle database, on this typical storage array, they couldn't query too much data at a time. That's a really difficult problem, but you know, people see a lot. If I look up, you know, if I search where this particular person has been yesterday, then it may be fast. But if you want to search for the whole week or a whole month, then it has to do so much I/O, you know, and scan through so much data, then it gets very slow, right? And these guys actually had to spend time and effort to build a caching system. So they built an in-memory cache in their app, so they could cache last 2 days. So even though they had this big and expensive database, they kept last 2 days in memory as well, so it would perform. And essentially, they could query 2 days at a time, right? And then they went back, you know, when they wanted to go back like a month and look into a whole week, it was too slow, right? People gave up. So they had this very elaborate caching system, but it was still not really, didn't solve the problem. And they couldn't rewrite that because they built this over the last 7 years. They've had so much code written for Oracle in PLSQL, so many incoming data feeds, outgoing data feeds, batch jobs, and so on. So you cannot just simply take your SQL and point it to Hadoop directly. And what we did for them was we installed Gluent. They scavenged the 3-node Hadoop cluster from in-house, you know, from some old servers, you know, for the POC. We offloaded most of their data from the biggest tables. You know, the small tables they left in Oracle. We don't care about them. But the biggest tables where this data actually was, and so basically we enabled Gluent. And they ran the query for the last 2 days. It was the same speed as previously. Then they ran the query for a whole week. It was still the same speed. They didn't notice a difference because you suddenly have this powerful Hadoop, scalable Hadoop engine in the backend with directly attached storage and columnar data structures and all this future magic, right, or the modern magic. And then they were like, okay, what about going back 5 years into history and look into a whole month of data, and boom, it came back in a couple of seconds again. So it's almost like they didn't even notice the difference, whether it was 1 month or 1 week. So previously it was like, you know, does it take 20 minutes to come back or 2 hours, or does it time out? So, and that's when they were like, okay, so if this thing is so fast now, we can actually do much more than just look for the needle in the haystack. Because, you know, it's easier to do the needle in the haystack query. It's like, hey, I know I want to look for Joe, right? And where was Joe last week, right? So that's easier to do. But what if